Okay, good morning, Math 10-3. This is your first tutorial video for the course. And if you have any questions, of course, you can meet me later on in the Zoom chat. As of right now, let's get started. And I will start by sharing with you my screen so we can take a look at a project here. All right, so what we were looking at before the break started and before everything kind of went all nuts is we were looking at lengths and perimeters. So we've got Monica walking around the outside of a building here in this example. She's going to be walking all the way around the outside. How far does she walk? Now, first off, we got to figure out if we're finding the perimeter or area of a building. Remember that perimeter is the area around the outside. So rather than looking at the area, which would be the fill, everything inside this, right, is how much it would take to fill this, we're looking at the perimeter. So how far it would take to walk along the edges, right? So what you might have some trouble seeing right here is this 7.5 meters, which is for this length here. Notice we got this blue line up here, which means that on the outside, we also have, where are my tools? Here they are, okay. We also have a 7.5 meters here. And notice I've put a 0.5. I just find that it easier to work with decimal for the time being than it is to work with fractions, because they add up more easily in my opinion. But you can leave them as 7.5 as long as you know how to add your fractions together. It's up to you. And then, so we've got this 15, 7.5, 15, 7.5. What's this bottom length going to be? Well, notice this 15 up here. It's going to be matched by 15 meters along the bottom here. And this 15 up here is going to be matched by a 15 meters along the bottom here. So this is covering it up. And then, of course, those get added together for this full distance along the bottom. And then over on this side, we're going to have this 7.5 and this 7.5 add together to give us another 15 meters on this side. So if when Monica's walking around the building, let's say she starts right here. I'll do that in red. Let's say she starts right here. She's going to walk 15 meters. Plus then another 7.5 meters. Plus another 15. Plus another 7.5. And you got to forgive my drawing. I'm using a mouse instead of some sort of pen tool. That brings her to here. And then another 15 meters and another 15 meters. Plus 15. Plus 15. And that brings her to here. And then another 7.5 and 7.5. And if you add all of those up together, you will get the answer, which is 90 meters total for your perimeter. Perimeter is 90 meters in this question. All right, so that's a bit of a review, what we were looking at previously. Now we want to move forward and we want to take a look at some surface area questions. And I'll have to clear this screen off, clear all drawings. All right, so one of the things we're going to be doing in section 3.3 is we're going to be solving problems involving surface areas of 3D objects. So your surface area, and this applies to any type of object we're looking at, is the total area of all the faces, every face on a 3D object. So if you take a look at an object like a rectangular prism, you've got this front face, you've got a side face, you've got the right side face, you've got the top face, you've got the bottom face, and you got the back face. There's 6 faces there. You get the surface area, you add all 6 of those up. So For some people, that can be kind of difficult to visualize. So we add this. It's the area that would be covered by a 3D object if you could lay it out flat. So now on this next slide, I've shown what are called nets. And a net is a two-dimensional pattern used to construct three-dimensional shapes, or a diagram of a 3D object seen as a flat surface. Take a look at this net of the cylinder. We've got the circle on top, we got the circle on the bottom, and then we've got the rectangle around the sides. And our radius is going to be the distance from here to here. So the area of this top circle is going to be pi times r squared. Sorry, I don't have a better way of showing squared. And then the area of this bottom circle is going to be the same. It's also going to be pi times r squared. Actually, I do have a better way of doing that, and that's just to draw it out manually, probably. I'll get slicker at doing these probably as time goes on. So pi r squared. This is also pi r squared. And then what about this rectangle in the middle? Obviously, we've got the height on the side that is going to be part of that area. But what's this length? And this length, when you think about it, if you were to unwrap the label around a can, that's where this rectangle comes from. So the length of it is just going to be equal to the circumference of your circle, which is 2 pi r. Right? Circumference of a circle is 2 pi r. And so the area of this inside is 2 times pi times r times h. 2 pi r h. Okay, let's take a look at the next one. We've got a cone. Again, area of the circle on the base is pi r squared. And the area of this sort of pie-shaped piece is a little trickier to figure out. And I won't ask you to figure it out. What I will do is give you the formula. It's pi times r times s, where s is this slant length right here. So that's the measurement from the top of the cone to the base of the outside. So if you were to measure along here, you get S. And that will give you the area of that wraparound part. We call that the lateral surface of the cone. Going back to our rectangular prism, as I said, there was this top part, the front, the bottom, the left side. Those are all represented here as the top, the back, the bottom, the front, and then our two sides here show up here. So you could cut this out, cut out a shape like this, fold it up, and you would get a rectangular prism created out of it. Same thing with a triangular prism. As you can see, there's a triangle on each side, and then 3 rectangles make up the outside of it. But let's do this with some real numbers and get a feeling for what's going on. So we'll move forward here. And again, I gotta clear all my drawings. Okay, so we have a net of a rectangular prism. And this might actually be easier if I use these tools instead. Select my pen. Here we go. With the following dimensions, we want to calculate the surface area. And recall that the surface area is the sum of all your surfaces, the area of each of your surfaces if you add it together. So the area of this plus the area of this plus the area here plus this area plus this area plus this area. And each of these areas, of course, is the area of a rectangle. Area of a rectangle, as you'll recall, is length times width. So this is going to be 3 times 6 is 18. This one's going to be, the side dimension is still 6, right? So this 6 is still here. So this is going to be 6 times 4. And that should be a times. So that's going to be 24 centimeters squared, of course, are the units. Area here, again, is 3 times 6. The top and the bottom are going to have the same area. So this is going to be another 18. And this one, again, we've got 6 in height, and the front and the back of the rectangle are going to have the same height. So this is going to be another 24 centimeters squared. And really, yes, the unit should be on all of these, but it takes a long time for me to draw like this. Okay, so then what do we have next? We know this is 4 centimeters wide, and this is 3 centimeters tall now. So this is going to be 3 times 4 equals 12. And this is also going to be equal to 12. So our total surface area is going to be area 1 plus area 2 plus area 3 plus area 4 plus area 5 plus area 6, all 6 added together. So 18 plus, I'm going to switch to text for this, it's way faster. 18 plus 24 plus 18 plus 24 plus my area 5 up here, which is 12 plus 12 down here. Let me just erase it. I erased the wrong one. Oh, that's because I'm in the wrong tool. Sorry about that, guys. Let's go back to the mouse and use my eraser for a moment. I thought it'd be easier on here, but all right. That one's just a weird one. Okay, sorry, this was 18 plus 24 plus 18 plus 24 plus 12 plus 12, which gives us a grand total of 108 centimeters squared. All right, any questions on this? I will ask you to direct them to me later on this afternoon. All right, so if we get a question like this, Jim has been hired to make a jewelry box. And if the box is 12 inches long, 6 inches deep, and 9 inches tall, how much veneer will it take to cover the exterior? So the hint here is to draw a net. It's a typical surface area problem. The exterior of the box is all of the surfaces on the outside, and veneer is just something that you use to cover the outside. So for this net, we're going to have a fairly big triangle for the top and bottom, or rectangle rather, for the top and bottom, right? And then we got a skinny rectangle for the outsides. Top and bottom are going to be about the same. And then again, so on the back, we're going to have this long skinny shape again. Now we have 2 more sides. We got the left-hand side and the right-hand side, and those are going to come off of one of these skinny shapes. And they should have the same length as that. And so your net might look something like this. It obviously doesn't have to be perfect, as long as you get sort of an idea of what it looks like. And in terms, pardon the noise, guys, in terms of sides, we have that it is 12 inches long. So this is going to be 12 inches along here. And it is 6 inches deep. That's going to be our depth. So length, depth, and then our height here is where we put our skinny amount. We're not to scale according to the question. That's going to be your 9 inches in here. So this is 12 by 6. This length again here is also 6 inches because when you fold this together, these two sides match up. Right, so our 12, 6, and 9 go that way. This is also going to be my 9 and my 12. And so we can take these together. We're going to have all of our separate areas in here. This one's going to be 12 by 6 equals 72. Right here, we're going to have 12 by 9 equals 108. This one's going to be 12 by 6 equals 72 as well. And finally, our sides here are going to be 6 by 9. So as you can see, we've got all these yes, we get 12 by 6 equals 72. We got all these areas we can add up. 72 plus 54 plus 108 plus 54 plus 72 plus 108. And when you add these together, this is 108 plus 108 is 216 plus 108 is, actually let's do this, 72 and 108 is 180. So 180 and 180 is 360 plus 54 and 54, that's another 108. 360 plus 108 is 468. And of course, these are square inches. And that's how much veneer we'll take to cover the exterior. Okay, I'm going to pause this and I'll take it up in a second part of the video.